Hi guys, today we'll be learning about transformations, chapter 14.1 to chapter 14.5. So 14.1, mappings and functions, has a few key terms. First one, mapping, a correspondence between points. Function, a correspondence of numbers in which each number in the first set corresponds to exactly one number in the second set. One-to-one mapping, a mapping from set A to set B in which every member of B has exactly one preimage in A. Transformation, a one-to-one mapping from the whole plane to the whole plane. Isometry, a transformation that maps every segment to a congruent segment. Congruence mapping and isometry. So this chapter has a theorem, theorem 14.1, and isometry maps a triangle to a congruent triangle. Corollary 1, and isometry maps an angle to a congruent angle. Corollary 2, an isometry maps a polygon to a polygon with the same area. So we got examples. Fill in the blank. F of x maps 5x minus 7. Image of 8. B preimage of 3. G of x maps 2x plus 6. A prime image of 7 equals preimage of 8 equals. So for A, image of 8 equals 33 because 5x, if you plug in 8 into the x, 5 times 8 is 40 minus 7 is 33. And preimage of 3, you make 5x minus 7 equals 3 and x is 2. A prime image of 7 is 2 times 7 plus 6, which is 20, so the answer is 20. Preimage of 8 is 2x plus 6 equals 8, so B prime equals 1. Preimage of 8.
This lesson is 14.2, which is about reflections. And reflection means that it's reflecting points to their images. The theorem 14.2 is a reflection in a line is an isometry, which means that a figure that is reflected on a line is isometry, which means it's congruent. And this picture is an example of a reflection. That means the point A maps to point A prime, and point B maps to B prime, and C maps to C prime. So triangle ABC is reflected against axis Y to triangle Y, A prime, B prime, and C prime. And for example, this figure, if this figure is reflected against the y-axis, then this point is reflected to itself because it's on the line. And this point is reflected here, and this point is reflected here. So it would connect like this, like a house shape.
So now we're gonna learn about 14.3, translations and glide reflections. A translation is a transformation that glides all points of the plane the same distance in the same direction. And a glide reflection is a transformation in which point P is mapped to a point P double prime. So there's a theorem for this chapter section. Theorem 14.3, a translation is an isometry. So this is a translation where A, B, C, D, the preimage maps to A prime, B prime, C prime, D prime. It's the translation of x comma y maps to x plus 8 comma y. And this glide reflection, this is the preimage, and it glides first over the y-axis and it reflects over the x-axis. So this is the image and that's the preimage. And there's an example. If translation of 0, 0 equals maps 5, 1, then translation of 3, 3 maps 8, 4.
Hello, welcome to 14.4, rotation. A theorem in 14.4 is theorem 14.4. A rotation is an isometry, and an isometry, as we all know, is a congruence mapping. Here we have rotation around point O, 90 degrees of triangle ABC. Always remember, positive equals counterclockwise and negative equals clockwise. Here we have positive, so we rotate 90 degrees counterclockwise. So here's our example. State another name for each rotation. Around point O, 80, and B, rotation around point A, 450. Now try it yourself. The solution for A was rotation around point O, 440, and for B, the solution was rotation around A, 90.
14.5 is about dilations. Dilation is either a contraction or an expansion of a figure. A dilation maps any triangle to a similar triangle. A dilation maps an angle to a congruent angle. A dilation D of O and K maps any segment to a parallel segment, absolute value of K times as long. A dilation D of K maps any polygon to a similar polygon whose area is K power of 2 times as large. Here are some examples of dilation. Triangle ABC here is getting expanded by 2 because it's dilation of point O of 2 on ABC, so it becomes A prime, B prime, and C prime. For some examples, it's a dilation and expansion or a contraction. A 3, 9, 2, 1, 3, B 0, 1, 6, 2, 0, 2 3. A is contraction because this vector is getting lower as 1, 3 from 3, 9, so that's contraction. And B is extension because this vector 0, 1, 6 is getting bigger by 0 and 2/3.
Thank you. This poster was made by
Annie Kim,
Eric Ma.
Tristan Hula.
And Justin Yoon.
Yay! To sum up what we taught you, here's the chapter summary.